All right, let's get started. Okay, normal distribution. You did this in algebra 2. Okay, shapes of the graph. Okay, so you've got skewed left. Okay, you've got skewed left. You've got skewed right. Okay, this goes down on the left-hand side. This goes down on the right-hand side. And then you've got unimodal symmetrical. Okay, also known as the normal curve. Okay, these are words that they use interchangeably. So you kind of need to be comfortable with them. Yeah. I don't know how to help you there. Yes. I don't think so. Brush out. Okay. Bimodal has 2 peaks. Okay. And then unimodal is all one the same. Okay.
Yeah, because I'm doing on old time innovation. I'm just thinking about it. Because I just call them heritage, you know. Maybe you're gonna make no money. That's maybe or can you just use drag that in the drag
All right, these 2 symbols, this is called X bar, and this is called mu. Okay, mu. That's what that Greek letter stands for, mu. Like the Pokemon. Yep. That's also known as the mean. Okay, S or sigma. Why does everybody laugh when I say sigma? I don't understand. That's standard deviation. Sigma? Standard deviation. You were today years old.
Just think that it was what's it called? Yes. I never heard that word. They put it in what do they call fraternities?
Yes.
Yeah.
No, not what he was talking about. Oh. Okay, normal distribution. Normal distribution is symmetrical on each side with a peak at the middle. Middle.
That's not
Okay. Middle. The data on each side is spread out by the standard deviation.
Were you in
I was in a sorority. So my hold on. The mean, median, mode are all in the middle of the normal distribution. Real life normal data. So this is talking about height, weight, shoe size, IQ, SAT scores, kernels popped when popping in a microwave, popcorn. These are all examples of a normal curve. Okay. All right. In normally distributed data, 68% of the data is going to fall within 1 standard deviation of the mean. 95% is going to fall within 2 standard deviations of the mean. And then 99% of the data is going to fall within 3 standard deviations of the mean. This is also known as the empirical rule. Okay, this is 68, 95, 99 rule. Okay. here's the hard part. Ready? Here's the hard part. It's because people don't pay attention to like the whole thing. So in the middle, we have, all right, guys, in the middle, we have the mean, okay? Then mean plus 1 standard deviation. Whatever your standard deviation is, that just tells you how far away from the mean something is, okay? So given a data set, we can use the curve to find the probability of certain values in the data falling within an area of the distribution. So right here, we want x is x minus 2 standard deviations. Okay, so x minus 2 standard deviations. So less than the 2 standard deviations. That means 2.35 plus 0.15. So 2.5% of your data. Does that make sense? Okay, on the next one, it says x plus sigma. Okay, so that's 1 standard deviation above. Okay, so when we go here, we want above that standard deviation. So 13.5 plus 2.35 plus 0.15. 0.15.
I know words. I knew it when we first did it.
Okay, when you add all that together, you get 16% of your data. Okay, this is where it starts tripping people up. Okay, is this notation right here. Okay, so this notation right here. I don't really know what she's got going on here. That looks weird. Okay, so we have x minus 3 sigma. Okay, x minus 3 sigma. That is located right here. Okay, and we want it up to, I'm assuming this means x bar plus sigma. Okay, so we're going to go all the way up to here. So that's 2.35 plus 13.5 plus 34 plus 34. So we're going to add all that together. And that's going to give me 83.85. Okay. Say it again.
Okay. Is this in the formula sheet?
So this picture will be, but that's, I think, it. Yes, ma'am. Safara.
Can you go through like how you find it?
Okay, so like if I had x minus 2 sigma and we want less than, right? So we're going to find x minus 2 sigma and we're going less than. So it's the numbers that are inside here. Less than would be to the left. Greater than is to the right. Yep. Everybody okay? All right. So looking at the next one, whenever you get this normal curve, the first thing you want to do is take all your percentages and write them down. Yeah. So you start in the middle. You got 34. You got 13.5, 13.5, 2.35, 2.35, and then 0.15. 0.15. Then they tell us information. They say the math scores for an exam for the state of Georgia are normally distributed with a mean of 480. This goes in the middle. You just go ahead and put it right there. Okay. Then they say a standard deviation of 20. Okay. So you're going to add 20 to 480. Okay. Until you run out of the lines. So 480 plus 20 is 500. 500 plus 20 is 520. And then you get 540. Okay. On the other side, we're going to subtract. So this is going to give me 460. 440, and 420. Okay, so what we're going to do is we're going to figure out what percent of the test takers received a score between 460 and 500. So we're looking for 460 up to 500. So what's 34 plus 34? Okay, so 68%. Okay, on the next one, it says scored more than 480. Okay, so let's look at how we got that. Scored more than 480. We go to 480 and we go more than. So that is 50%. On the next one, scored less than 440. So we go to 440 and we add these two together. So that's 2.5%. Everybody see how I did that one? Okay. Go ahead and take a moment. Try the next one. Check your work. Questions, comments, concerns.
I got, yeah, I got 81.5.
We're wrong.
What's the possibility?
There is a possibility. I was listening to y'all chat about whatever. It is 81.5. Yeah.
What?
84?
Do it, Charles.
We don't want that, bro. That's a different person.
No, it's 84. Sorry, I kept on putting 64 instead of 68 when I was doing it. Oh, my bad. All right, so z-score. A z-score reflects how many standard deviations above or below the mean a value is. If a z-score is positive, it lies above the mean. If a z-score is negative, it lies below the mean. Have I got it?
I'm sorry. I'm sorry, so many things. See?
Like, I'm not even. Oh, okay, I'll tell you. All right. It's so upsetting. All right, so there is a formula to find the z-score of a value. Okay. So x is going to represent whatever point you're trying to find. X bar represents the mean, and then sigma represents the standard deviation. I'm laughing. Okay.
I'm not saying number.
All right, so we're going to use this example. So suppose SAT scores among the college students are normally distributed with a mean of 500 and a standard deviation of 100. If a student scores a 700, what would be her z-score? So what you're going to do is you're going to take 700, you're going to subtract the mean, we're going to divide by the standard deviation. So 700 minus 500 is 200. 200 divided by 100 is 2. Her z-score would be 2, which means her score is 2 standard deviations above the mean. Yeah.
And where does the big chart of all the decimals come from?
I'll show you in a second. Okay. So we got the mean of 500. So homegirl lies within this section. That's what this is saying. Okay. All right. In Harold's math class, a recent test had a mean of 70 and a standard deviation of 8. In Harold's English class, a recent test had a mean of 74 and a standard deviation of 16. If Harold earned a score of 78 on both tests, then which subject is performance better? So here's the point with the z-score. It's taking two things that have a different mean and being able to compare them to see which one you did better on. Most of the time we use this with testing. Okay, so you're going to talk about his math class first. So he got what score on his math? He got a 78. on his math score with a mean of 70. And we're going to divide by 8. Okay. In English, in English, he got a 78. The mean is 74. And the standard deviation is 16. So tell me, what were his z-scores for these? One? Yep. 0.7. What is it?
0.25.
0.25? Okay. So which one would be better? Well, he did better on the math score since it's one standard deviation above the mean, while the English score is only 0.25 standard deviations above the mean. Everybody got it?
Wait.
Questions? Okay, you try the next one.
I had to try this.
Yep. Okay, so the mean speed of vehicles on a stretch of highway is 56. Standard deviation is 4. So you're going to do 62 minus 56 divided by 4. You're going to do 47 divided by 56 divided by 4. 56 minus 56 divided by 4. So 0 is the last one.
Eureka.
Lord almighty.
You can get negatives on this one.
Yes. Yeah. So you can get negative 2.25 on that one.
Then 1.5.
So 1.5 on the first one. Questions? Okay, z-score tells me how many standard deviations away from the mean something is. Okay? In order for you to compare two datas, you have to turn them into z-scores in order to convert them, like to talk about them comparatively. Okay? All right, finding probabilities with z-scores. Test grades from topic 13 tests were sampled and they have a mean of 75 with a standard deviation of 5.5. What's the probability of score being less than 93? All right, so what you're gonna do is first you gotta find the z-score. So you got 93 minus 75 divided by 5.5. So that's going to give you 3.27. All right, here's the fun time. Ready? We're going to use our z-score table.
Already?
Yeah.
No.
I just work here. Okay, ready? This is how you do it. Is it positive or is it negative? It's positive, so we're going to go to the positive page. Okay, it's 3.27. Okay, so looking down here, you're going to look for 3.2, and then you're going to go over to 0.07. We're going to go down to 3.2 and over to 0.07. 0.07 you're going to read up at the top.
I don't know if I can be able to check it that way.
I mean, I'm going to give you a hard copy in just a second.
All right.
This is going to give you 0.9995. So 0.9995. Yes, once you get to that level, yes. Okay. So what is the probability of being at least a 68? So again, you're going to find the z-score. So 68 minus 75 divided by 5.5. It is going to be negative. So this is going to give me, I got 1.27. Negative 1.27.
Oh.
Okay. So then we're going to go to the negative z-score table. And we're going to look for negative 1.27. So that's going to give me 0.1020. 0.1020. Here's the problem. Look at what the question asks you for. At least. Whenever they say at least, you're going to do 1 minus whatever number that you found from the table. So 1 minus 0.1020. That's 0.898. Okay. On the last one, you're finding the probability, guys. You're finding the probability between 73 and 83. So you're going to find the z-score for each. You're going to find the probabilities for each. And then you're going to subtract those two. Okay, so what I want you to do is take a moment, find the z-score. And we're going to negative 0.36. So we're going to go up here to negative 0.3 and over 0.06. So that's going to be 0.3594. So 0.3594. Then, what was our other number?
1.45.
Okay, so we're going to go to positive 1.405. That's 92.65. Okay, you're going to subtract those two because they're in between. That's what we're trying to find. Oh, 0.9265 minus 0.3594. And that's going to give me 0.5671. Okay. All right, your turn. You try these. Yep. This says less than 83. Okay, take a couple minutes. You're trying those four. So you should have gotten 83 minus 75 divided by 5.5. You plug that in. You get a z-score of 1.45. But we're not done because they asked us to find the probability. We're going to go into our table. We're going to look for 1.405, and that's 0.9265. So that's 92.65%. Okay. The next one, probability of a test score being no more than 71. So 71 minus 75 divided by 5.5. 4 divided by. So that's going to be negative 0.73. Go into our table. We go to the negative section. 0.73, that's 0.2327. That's 23.27%. Okay. On the next one, it says at least. So when we get our probability, we're going to do 1 minus that probability. So we're going to do 78 minus 75 divided by 5.5. That's going to give me 0.55. Go into our table. That's 0.7088. But we're going to have to do 1 minus that because it says at least. So that's 0.29112. I'm sorry, 12. Okay. Questions on that one? Are we okay on those three? Okay, the last one, you're going to find the z-scores go and find the probabilities and then subtract them. Yep. The 6. All right. On the last one, you're going to do 63 minus 75 divided by 5.5, 84 divided by, minus 75 divided by 5.5. So this one will give you negative 218. And this will give you 1.64. We go into our table. 1.64 is 0.9495. And two one oh eight 0.0146. So we subtract these two. And that's going to give me 0.9349. Okay. Now, most of the time when we say probability, we're talking about a percentage. So we would say 93.49% are doing whatever. Okay. Everybody good? Okay. I want you to get a little bit of practice with this because this is a little bit on your quiz / it should be easier. Okay. So I'm going to give you a worksheet and you're going to turn in the worksheet by the end of class.